Okay, how do you find 0 as a quadratic function? If it's in the general form, you can factor it if it's factorable, which it usually isn't in the real world. We still need to know how, okay? Or you can use the quadratic formula. I probably ought to write out that. Okay? Otherwise it looks like form. Or in the standard form, in which case the solution is really easy. Would you all agree? In standard form, it's easy. Now I'm talking mostly to the MCR because we did this in detail, right? So I'm just going to refer to it. In the general form, your zeros are at the points that are indicated by the quadratic formula, right? And you have three possible cases. In one case, this discriminant, this thing under the square root, is positive, in which case you have two different solutions, one for the plus and one for the minus. If the thing inside the square root here is 0, if the discriminant is 0, then plus 0 or minus 0, you get the same thing, right? Adding 0 and subtracting 0 from a number give you the same number. So all you get is your negative b over 2a, which of course is the x-coordinate of your axis of symmetry, right? So that means your zeros are on the axis of symmetry, which means that your parabola is either sitting on the x-axis, at, just touching it at one point, or it's upside down being suspended from the x-axis at that one point. Or you get two complex conjugate zeros, and the first section of the chapter, which we haven't talked about, is about complex numbers. It's the easiest section in the course, and we'll pick that up probably later this week. Okay, if you know the distributive law and know that square root of a negative can be factored into the square root of -1 times a positive number, so you get the I thing, and you do know that. Okay, then you're going to find it's easy, except for dividing. Dividing two complex numbers can be tricky. Okay, so anyhow, you get two complex conjugate zeros, like negative b plus something times I, negative b minus something times I, over 2a, right? And in that case, the graph doesn't intersect the x-axis. The graph is either totally above the x-axis, opening upward, or opening downward and totally below the x-axis. Okay, well, that's what you get from the quadratic formula. You know easily by looking at the discriminant which case you have, so you know how many times the graph goes through the x-axis, if at all. Okay, and you know whether the function has a solution for a given value of x. Okay, well anyhow, if the thing factors, if this expression factors, it can be written as a times x minus z1 times x minus z2. Okay? That's what we mean by factoring it. Factor out the a, and then factor what's left into product of two binomials. Okay? Now again, in the real world, usually you can't do that because real world data almost never gives you rational solutions. Almost always irrational, and if it's irrational, you can't find the factors. Okay? At least you can't count on finding the factors. You can't expect to find them, except by using the formula. Okay, in that case, you have this equal to 0, right? Okay, if it's in the general form, you can, and you can factor it, you can write the equation this way. And the only way this is going to be 0 is if either x minus z1 or x minus z2 is 0, giving you solutions x equals z1 and x equals z2. And incidentally, the axis of symmetry is going to be halfway between those. Because if you got the zeros here and everything's symmetric, the axis of symmetry has to go right between the zeros, right? So it's kind of important to know that and understand it. And we did an example, x squared plus 5x plus 6 equals 0, easily factored, x plus 3x plus 2 equals 0. So that either x plus 3 has to be 0 or x plus 2 has to be 0. If x plus 3 is 0, then x is negative 3. If x plus 2 is 0, then x is negative 2. Okay? That can't be both. It's either this or this, right? Meaning that this and this are now solutions to the equation. So now if we want to graph the thing, if A happens to be positive, we know the graph is going to look like this. It's going to go through -3 and -2. Your y-axis is over here, and the axis of symmetry is halfway between the two zeros.